This is for Specialist Maths question 6 from exercise 2c of chapter 2. So I've explained to this in class on how to solve these using a graphical method. Now I'm going to show you the number line method. So looking at question 6a, we've got a situation where we've got two modules functions subtracted from each other equals 6. So in order to solve these, we can use something called the number line method. We know that each module's function can be separated into two pieces. So for example, when we have the modulus of x minus 4, we know that it can be broken down into the positive piece and the negative piece. And they cover different domains, because if we draw it, we know that, so the modulus of x minus 4, we know that the 0 occurs at 4, and it's positive here. Normally it will be negative there, so what happened when we put in modulus is it became positive as well. So it looks something like that, and we got two pieces, one here, one there. That's why we have two pieces here. Similarly, for the modulus of x plus 2, we separated into two pieces, so this piece and that piece. Now, the trick here is to know when the various modulus terms equals 0. So for the modulus of x minus 4, it equals 0 at 4. So I've written 4 on the number line. And for the modulus of x plus 2, it equals negative 2. So I've written that on the number line. And what we've done here is divided into three regions. So region 1, region 2, region 3. Region 1 is when the graph, or the section where x is less than negative 2. The second region is when x is between negative 2 and 4. The region 3 is when x is greater or equal to 4. Now, I want to solve the equations for each different region. So I would have three different equations to solve, because it depends on what the positive or negative piece I choose for each of these modulus functions. So for the region x less than negative 2, we know that the piece we choose is the negative version for the first modulus expression, and for this piece, for this expression, we choose the negative piece again, because at x is less than negative 2, i.e. less than 4 or less than negative 2, we have both of them being negative. So in order to remove the modulus signs, I've just simply times whatever's inside modulus by negative and remove the modulus sign, and form the equation like that. So solving this equation, we get 6 equals 6, which is correct. So it means solutions occur when x is less than negative 2. For region 2, we did the same thing. However, we know that when x is greater than negative 2 but less than 4, we have to choose which pieces we use. So when x is greater than negative 2, we know that we use this piece for this expression, and we use this piece, because it's still less than 4, for this expression. So we sub those into in place of the modulus terms. So x minus 4 becomes, modulus of x minus 4 becomes minus x plus 4, since we're still taking negative version. So I just times whatever's in the modulus by negative 1. Now for the other term, I just leave it alone. So negative whatever's inside, I left alone. So it's x plus 2. And obviously everything equals 6. So minus x plus 4 minus brackets x plus 2 equals 6. I simplified it, and I got x equals negative 2. That's also a solution for us. So we've got two solutions at the moment. Now, it's a solution because it corresponds to the domain we've given. So x between negative 2 and 4. And that is within that domain, so that's an acceptable solution. For equation 3, we know both, so we're looking at the domain x greater or equal to 4. we know for x greater than or equal to 4, we choose this term and this term. So both are positive. So we can ignore the modular signs and treat them as like normal brackets, which is what I've done here. And I solved it. I got -6 equals 6, which is nonsense. So there's no solution for this equation. So our overall solution would be these two. If I combine these two, I get x is less than or equal to -2. And that's what you should get for your final.